Hello and welcome to today's lesson where we're going to look at the electromagnetic spectrum, which is a topic in the Waves module of GCSE Combined Science Physics. So in today's lesson we're going to try to define and describe the electromagnetic spectrum. So if we're successful and we learn in today's lesson, you should be able to define what an electromagnetic wave is, understand what the electromagnetic spectrum is, and describe the uses of the electromagnetic spectrum, which falls into the following part of the GCSE Combined Science specification for physics. So we're looking at types of electromagnetic waves and uses and applications of electromagnetic waves. So an electromagnetic wave is a transfer of energy from one place to another place using the vibrations of the electric and magnetic fields in the universe. So electromagnetic waves are transverse waves that transfer energy from the source of the waves to an absorber. Now, because the electromagnetic waves are vibrations of the electric and magnetic fields which exist everywhere in the universe, this means electromagnetic waves can travel anywhere in the universe. Electromagnetic waves do not need a material to travel in, they are the material themselves. So electromagnetic waves form a continuous spectrum, and all types of electromagnetic wave travel at the same velocity through a vacuum or air. So it's important to know that all electromagnetic waves travel at the same speed as each other. So electromagnetic waves can change if they move through different materials. The denser the material, the slower the electromagnetic waves travel. The less dense the material, the faster the electromagnetic waves travel, which is observed in a process we observe as refraction. Now, all electromagnetic waves change speed by the same amount, because like we mentioned before, all electromagnetic waves travel at the same speed. Now, a special type of electromagnetic wave is visible light, because visible light is the only type of electromagnetic wave which our eyes can detect. So to clarify, an electromagnetic wave is a transverse wave and does not need a material to travel in. Electromagnetic waves can travel through a vacuum-like space, and it also has another special property. All electromagnetic waves have the same speed, and which is 300 million or 3 times 10 to the 8 when the electromagnetic wave travels through a vacuum, which is the fastest speed known in the universe. Now, the equation to work out wave speed is wave speed in meters per second is equal to frequency in hertz times by wavelength in meters. So it's important to note that because all electromagnetic waves travel at a speed of 3 times 10 to the 8 meters per second in a vacuum, that because the wave speed is always 3 times 10 to the 8, that the frequency and the wavelength must multiply together to give this number. So because the wave speed would remain constant, this tells us that when the frequency goes down, the wavelength goes up, and when the frequency goes up, the wavelength goes down, because the two values have to times together for the wave speed to remain constant. This is shown if, for example, we said the wave speed was 12. Obviously it's not, but let's just look at it in this example. So you could have 1 times by 12, 2 times by 6, 3 times by 4, 4 times by 3, 6 times by 2, and 12 times by 1. Now, in all examples, those two numbers times together to give the same value, 12, but you'll notice as the frequency went up, to compensate for this, the wavelength went down. So it's important to note, like we said before, that for electromagnetic waves, as long as the wavelength and frequency multiply to give the wave speed, then any possible value of this can exist. So when the frequency goes up, the wavelength goes down, and when the frequency goes up, the wavelength decreases like this. So this means it's possible to get a very large number of different electromagnetic waves, going from low frequency to high frequency and long wavelength to short wavelength, with the only caveat being that the frequency number and the wavelength number have to multiply together to give out your wave speed, which is the same value. So this leads to a continuous spectrum of waves called the electromagnetic spectrum, and we can group the different parts of the electromagnetic spectrum into different regions. Now, the waves in each region have similar wavelengths and frequencies, but all the electromagnetic waves have the same speed. So in these different regions, you've got to be able to memorize where each region information lies in the electromagnetic spectrum, which is very, very important. So to clarify, for all electromagnetic waves, as long as the wavelength and frequency multiply to give c, the wave speed, then any possible value of this can exist. This gives a continuous range of values called the electromagnetic spectrum. This range can be split into different regions which lead to the different electromagnetic waves. So because every electromagnetic wave must travel at 3 times 10 to the 8 meters per second in a vacuum, as long as the wavelength and frequency multiply to give c, then any possible value of this can exist, giving us our continuous range of values called the electromagnetic spectrum, and this range can be split into different regions which lead to the different electromagnetic waves, which is shown in this particular animation here. So you can see the different regions of our electromagnetic spectrum. Now, again, here's another example of this. So you have your radio wave, then your microwave, then your infrared, then your visible, then your ultraviolet, then your X-ray, and then your gamma ray. And it's going from a long wavelength short frequency, going down to a high frequency short wavelength. Now, so let's just recap what we have learned so far. Every electromagnetic wave must travel at a speed of 3 times 10 to the 8 meters per second. For electromagnetic waves, as long as the wavelength and frequency multiply to give c, then the electromagnetic wave can exist. This gives a continuous range of values called the electromagnetic spectrum, and this range can be split into different regions where waves are grouped into terms of wavelength and frequency. So the different parts of the electromagnetic spectrum from long wavelength and low frequency to short wavelength and high frequency are as follows. It goes radio waves, microwaves, infrared, visible light, ultraviolet, X-rays, gamma rays. Now remember, all regions of the electromagnetic spectrum have the same speed, 3 times 10 to the 8 meters per second. Now the greater the frequency of the electromagnetic wave, the more energy the wave delivers per second. This makes high frequency electromagnetic waves more dangerous to humans. So the dangerous electromagnetic waves are the high frequency ones, ultraviolet, X-ray and gamma ray. So we call these the ionizing radiation of the electromagnetic spectrum, because this radiation, which can ionize your cells, cause them to mutate and turn cancerous. So the main types of ionizing radiation are gamma waves, ultraviolet rays, X-rays, and along with alpha particles and beta particles, which you've learned in the atomic structure module. Now, ultraviolet waves are ionizing and can cause skin to age prematurely, and it will increase the risk of skin cancer. But X-rays and gamma rays are the ionizing radiation that can cause the mutation of genes and lead to cancer. Now, the likelihood of this radiation having a hazardous effect on the body is given by its dose. Now, the dose of radiation is determined by the type of radiation, ultraviolet, X-ray, gamma ray, and the size of the exposure. So it's very important to note this idea that the dose is the size of the exposure of the body to the radiation, and the radiation dose is measured in sieverts, because the likelihood of the radiation having a hazardous effect on the body is given by its dose. Now, there are also different uses to the electromagnetic spectrum regions as well. So for radio waves, we use them for television and radio. Microwaves, we use them for satellite communication and cooking food. Infrared, we use those for electrical heaters, cooking food and infrared cameras. Visible light for fiber optic communications. Ultraviolet for energy efficient lamps and suntan beds. X-rays, medical treatments and scanning, and gamma rays, medical treatments and sterilization. Now, X-rays, the medical treatments, are as commonly called X-rays or radiographs, whilst for gamma rays, the medical treatment tends to be radiotherapy. Now, as we mentioned before, the ultraviolet, X-ray and gamma rays are the dangerous high frequency waves. So because they are ionizing, they've got to be treated with care as you use them in your everyday appliances. So what have we learned in today's lesson? Electromagnetic waves are transverse waves that transfer energy from the source of the waves to an absorber. Electromagnetic waves form a continuous spectrum, and all types of electromagnetic wave travel the same velocity through a vacuum or air. The waves that form the electromagnetic spectrum are grouped in terms of wavelength and their frequency. So from long wavelength to short wavelength, it goes radio wave, microwave, infrared, visible light, ultraviolet, X-rays, gamma rays. Our eyes can only detect visible light light and so detect a limited range of electromagnetic waves. And you should be able to give examples indicating the transfer of energy by electromagnetic waves. And we've got our practical applications of electromagnetic waves. Radio is used for television and radio there. Microwaves are used for satellite communications and cooking food. Infrared is used for electrical heaters, cooking food and infrared cameras. Visible light is used for fiber optic communications. Ultraviolet is used for energy efficient lamps and sun tanning, and X-rays and gamma rays are used for medical imaging and treatments. So if you've been successful and you've learned in today's lesson, you should be able to define what an electromagnetic wave is, understand what the electromagnetic spectrum is, and describe the uses of the electromagnetic spectrum. I hope you've enjoyed today's lesson looking at the electromagnetic spectrum, which is part of the waves topic in GCSE Combined Science. Thank you and have a lovely day.